All right. Hello, everybody.
Welcome, welcome.
So low, too. As you guys can see, we have a cool new setup. Plus, we have a special guest in the office with us for today. So we thought it'd be way more fun to actually bust out the green screen and try it out. And so let us know what you guys think. Also, we're still trying to decide what we want to do next week. So if you guys have an idea for a topic you'd like to hear about, feel free to either email it to us at contact@glass or just send it directly to me at adam@glasseducation.org. That'll probably be the fastest and easiest way for me to get it. And hopefully by Monday we'll have an idea for it. There's only 2 people on.
I don't even.
Right. All right, we'll just wait for a couple more people to get on. Feel free to go and share it on Facebook. Let your friends know that we're starting soon. Hi, Alex. Oh yes, Deb, doesn't the green screen work so marvelously outside of when my hand gets chopped off? Yeah, we're we're actually live in person at this random grass field.
We're just on the grass, getting eaten by the mosquitoes.
Oh, you can actually almost see.
Hello,
Yeah.
Kyle. Yay.
All right, Kyle's joined us already. We'll probably wait another 5, maybe even 7 minutes before we really get going here. But yeah, let's just start streaming into the comments. We're still working on a topic for next week, so if you guys have ideas for topics, pitch those now in the next couple minutes or send us an email. And yes, Kyle did also provide us with a boost of information for this week's show as well. I think at some point we're going to have to give Kyle a credit somewhere in the planetarium show.
Oh, definitely.
We might have to start making a credit slide.
Add that.
We'll contact you, Kyle, with what you want your title to be. Are you an executive director, consultant? We'll figure that out. Right. So you're all set?
Yeah.
Cool.
This is great.
Alex, I'm going to need to see a demo of your inclined plane physics sometime tonight or tomorrow. So make sure it's ready to go soon. I want to see if you can roll that ball up the plane yet. All right, yes, we'll wait another 5 minutes before we jump right into our topic for today. Also, Jeff's not even on yet. It's not clear, so I'm sure we'll see him soon. Alex did finish. We're good.
Oh, wonderful.
Hey Tim, how's it going? Thanks for tuning in. By the way, we are also going to talk a little bit about personal stories with solar eclipses, and I know multiple people that are already on here uh, have experience with solar eclipses. Like us tiny people. Let's see. Yeah, Jeff, we took advantage of the clear night on Wednesday night to go take the telescope out here in Williams Bay. We were planning to do it after the show tonight, but the forecast didn't look promising, so we took advantage of Wednesday night.
We'll see how the clouds roll today.
Hopefully they give us a nice little window.
See, try out. Oh wow. Every single day almost. Oh, that's awesome.
And where was the email to let us know to join you?
Right?
I would have worn my mask. Still no sunspots? Ugh.
Because a couple of days ago we saw there was a nice prominence on the sun.
Yeah, I think on Wednesday. 3 a.m. each day.
Oof.
Dang. Go, Jeff.
I just... Oopsies. Oh, hello, Bob.
Can you turn your mic up a bit? You seem quiet. I think that's actually just Katya and I talking too quiet.
We'll be louder for the actual show.
Yeah, enthusiasm takes a nice ramp up once we start getting into the show, which I think we'll just go ahead and start doing now. But also, thank you for joining us, Bob. So we're going to just jump right in. So I'm assuming you guys all either saw the Facebook post for today or saw it on our website or wherever you saw the announcement, but we're going to be talking all about the sun and eclipses specifically because this Father's Day features an eclipse. Unfortunately, if you only saw the post and got excited about an eclipse for Sunday, you might have to get on a plane tonight or tomorrow if you actually want to catch it, as it'll be 2 a.m. here and unfortunately not visible for us. But we're going to talk about it anyway because eclipses are still really cool, and there's an eclipse that I was about to say only 4 years away. That does feel like a long time, but you know, 4 years can fly really quick. But we're also, so we're going to talk a little bit about the eclipse in 2024, since I hope everybody here is able to get somewhere where they can see totality. And we'll be talking about our own stories in a little bit. So if you guys have a cool eclipse story, start typing it out now, because I would want people to start sharing that stuff in the chat when we get there. Mainly for today, I want to focus a little bit on Stellarium. So Stellarium is one of the tools, is the tool that we use for our live shows. And so we're going to be kind of exploring what you can do with that. And we are going to just kind of go through steps of what to do with Stellarium in order to prepare yourself for an eclipse and to check what an eclipse looks like from where you are, or to help you plan your destination without looking at one of those maps and just taking your best guess. There are a lot of good tools out there though. I know NASA always puts out a really, really good one. Astrophyric shows bad skies. Darn. We were hoping for good skies tonight. Oh well. We still have a perfectly clear sky here in Stellarium, so we'll take advantage of that for now. So now I kind of cheated. I already put us in a location where this eclipse is going to be visible. And if you did notice, if you look a little bit higher up on the screen, you can kind of see there's something near the sun there.
That's not a gigantic sunspot.
That would be quite a large spot, especially once we zoom in and you get to take a closer look. So the first thing that you want to do is figure out your location. So going to the location window on the left-hand side brings up this really cool menu, and you can put in just about any city you can think of. Even Williams Bay is in this list, so as long as it's an even somewhat relevant city, you can put it in here and get to your location. If you want to be more specific, you can put in your latitude and longitude. We normally just set it to Yerkes since we are just down the road from the observatory. That tends to work well enough for us here. Right now, though, we had to go kind of in Central Africa because that's where the eclipse will be visible. Unfortunately, the eclipse won't be visible for us as it'll be about 2 a.m., but you can actually still look at observe it through live streams. And there are a lot of options, including a friend of ours, and we'll be sharing that link on Facebook either later tonight or sometime tomorrow. So keep an eye out for that if you want to see what the eclipse looks like from, I'm going to let Katya pronounce the city in Russia.
Irkutsk, Russia.
Yes.
And note that in Irkutsk, it won't be a completely total eclipse. It's going to be a partial. So you only get to see a little bit of the sun eaten. But nonetheless, they promise that there will be commentary in both Russian and in English that you enjoy.
Yeah, so you don't have to brush up on your Russian before you go watch the live stream.
Yes.
So now for Stellarium. So I already picked somewhere that I know we get the full eclipse, or the full annular eclipse. And then it was just a matter of getting the time and date right. And luckily, Stellarium could not be easier to use when it comes to picking the time and the date. And another thing you can do is you can just go to a location and play time forward a little quickly and figure out what it looks like from that location. Now, the best way to watch an eclipse in Stellarium, simply go to the search menu, hit the sun, and it's really nice because Stellarium will automatically focus, put the sun at the center, and it makes zooming in a breeze. And as you can see, if we zoom back out a little bit, here you can see the moon just a little bit off of the sun, and we'll be playing time forward in order just to watch the moon get a little bit closer. So now what you want to do is you want to bring up that window that I closed a little earlier than I should have. We'll get a little bit closer. And if you just take the time over here, and actually we have to go backwards because this eclipse happens fairly early in the morning in this part of Africa. So here we're just after sunrise. And if we go minute by minute, you can see the moon going over the sun as it's slowly moving through its orbit. Now, one thing to keep in mind is that this eclipse is not a total eclipse. This is what's called an annular solar eclipse. So the moon does not actually completely block out the sun. And that's kind of confusing when you think about it, because we normally don't think about how the moon actually varies in its distance from Earth. Just as the Earth is not always the same distance from the sun as we orbit, the moon also goes through a very similar motion. So if the moon happens to pass in front of the sun when it's actually a little bit farther from Earth in its motion, in its orbit, that is enough to make the moon look too small to actually completely block out the sun. Now, during this total annular eclipse, only 0.6% of the sunlight of the sun is still visible, but it's still enough where you don't get that complete darkening effect like you do during a total solar eclipse. It will darken some, but I mean, it's also happening in the morning, so it wouldn't be that noticeable anyway. So once you find the location where you can actually really view the eclipse well, then you can actually just play time forward and watch the eclipse a little bit. Now, we were actually really lucky in that Kyle Cudworth, if you're not familiar, a former director of Yerkes Observatory, helped us out with a little bit of research and provided us with some cool photos. And one of the photos that he gave us was a picture that he actually took of a annular eclipse. So here we have an annular eclipse, and if you want to know a little bit more about when that eclipse was, I'm sure Kyle will be more than happy to post that information in the chat. But as you can see here, it doesn't fully block out the sun, and so this eclipse is also still dangerous to look at because there's still enough sunlight coming that can hurt your eyes. And we are all about safety here at Glass Education, so we're actually prepared. We already have our Eclipse glasses, and these are great tools to have. You will want them if you're ever going to go see an eclipse, because before totality, you need to have these on. It's not safe to look at the sun, and it's always just a good rule of thumb to never look at the sun, but the only time you can is when you use the proper equipment. These glasses are in that category of proper equipment, but unfortunately, the screen is not bright enough for any light to get through these glasses, so I'm gonna have to take these off for the rest of the show. And we're gonna bring that picture down of the annular eclipse.
And notice how the annulus around the sun gives us its name.
I didn't. Ah.
Because you can still see the little ring of sun around. While total solar eclipse, which we'll talk about next, then we have entire blockage of the sun.
Yes, and this is why you want a professional astronomer on your show. So, I'm sure I think I already saw some people were pointing out that they witnessed the solar eclipse back in 2017. We also were lucky enough to witness that eclipse. I believe that was before we met each other, though. So yes. We were in very similar locations, but that was already 3 years ago. So now I'm gonna show you exactly the process that I did earlier of figuring out where to go. Now, if you watched the news leading up to the 2017 eclipse, you probably heard the name Carbondale a billion times. And it's part of the reason that Carbondale was a zoo during that eclipse. Am I misspelling Carbondale? No, there it is.
There it is.
So as you can see, we did not change the date and time yet. This is what our sky is going to look like during the annular eclipse. Not too exciting, but check out one of those live streams, although it will be pretty late at night, so just keep that in mind. But now the next thing we have to do is once we set our location, we have to change our date and time. So for anybody that does not remember, the 2017 eclipse was in August the 8th, right?
Yes. Yes. First.
And we want to go back to the middle of the day. And as I mentioned, a great tool. Finder window is awesome, especially if you know something's already up. You can just go search it and it will bring it up nice and easy. So as you can see, we already brought this up where the moon is getting really close to the sun. And we'll play time forward. We'll go a little bit quicker. And you can watch the time elapse and you can really see how long a solar eclipse really takes. Because if you go outside and you look up at the moon, it doesn't really appear to be moving, but when you fast forward time like this, it really starts to move a little quicker.
Just note, Stellarium doesn't show things like weather. I remember that, unfortunately, I wasn't in Carbondale, I was north of Carbondale. but I had friends there who told me that they were clouds right during totality.
That is the risk you take when you try to go pick a location for a solar eclipse. And I remember, yes, so right after 1, about when totality occurred, and
darkness.
There we go. Now the moon is actually close enough in its orbit, it should darken once. So you get almost a twilight feeling, but in the middle of the day. And I remember specifically on this day, it was about 90 degrees.
Yep.
I was in Metropolis, Illinois, right by the Kentucky border. It was 90 degrees, and we had clouds right up until totality began, and all the clouds moved apart, and we were able to see the totality for the entire time, and it was wonderful because it dropped what felt like 20 or 30 degrees, and that was a wonderful relief.
We were having a picnic out there, and it was very hot.
So I also have some more pictures, courtesy of Dr. Cudworth. And I want to bring these up. So here we have a picture that he took of the totality. And if you noticed before, it does actually look similar to what Stellarium is showing us. Here is the one time you can actually see the corona. We also know that this, a solar eclipse, but in Africa back in 1921, was also what solidified and helped prove one of Einstein's theories about gravity bending light. Oh, is time still playing?
Yes.
Oh, I don't want totality to end.
Yeah, so notice, as Adam said, you can see the kind of outer, like, halo around the moon, which is the corona of the sun, which is the outermost layer of the sun that we actually can't see from Earth because of all the sunlight, like how bright it is, unless we get something like a total solar eclipse. And so scientists traveled to far extremes in order to go see these solar eclipses, just in order to study things like the corona.
Yeah, and one other fun thing to keep an eye on, when you go see a solar eclipse, there's also another phase. So right before you get to totality, there's a phrase called the diamond ring. So there's just that little bit of the sun still poking out, and that light is still bright enough to give this effect. And if you notice the white kind of almost band around it, you end up with what looks like a diamond ring. And it only lasts for a little bit, but it is really, really cool to see. And Kyle, you got an awesome picture here of that. I mean, you could not have timed that better.
Yeah. And you might note that we are saying corona, which is very close to, you know, COVID, the coronavirus, which the virus, I believe, was actually named because the virus itself it has like little spikes or whatever coming out of it. So it actually looks like the corona of the sun. That's why they named it that.
So coronaviruses are named because of the corona of the sun?
I believe so.
Well,
there's a whole bunch of different kinds of coronaviruses that, like, they've existed before. So they named it like way back before all of this happened. But yes.
Yes, this is the good corona. This is the one we want to see. Now we are going to, I wanted to also demonstrate that you really do have to be in the right place at the right time. If you've ever looked online, you can see those cool maps where they show you the pathway of totality, where all of the darkness is. Those are really helpful, but you can't always be sure if the town you picked on the map is right in that area. So Solarium is a really useful tool for that. So we're gonna just go back a couple minutes, make sure we're in totality. Oh, went back too far. And we're actually going to change our location on the map, and you can see how just changing your position a little bit and latitude-wise on Earth really affects your point of view of the moon and the sun, and can change what you see during an eclipse. So we can take date and time down. We'll move this over our heads. So one thing is, I know that there was a really cool star party here at Yerkes on the day of the eclipse. but they weren't in the line of totality. So this is the peak of the eclipse that they were able to witness. And this is what's called a partial eclipse. So now we have seen an annular eclipse, a total eclipse, and this is, did I say annular the first time? Annular, total, and partial.
Yes.
And so this is a partial eclipse. And if you're in Wisconsin, this is about what you're going to see in 2024, as that eclipse will take a similar path, but just going from the southwest up to the northeast instead of the northwest to the southeast. But Carbondale is actually lucky enough to get this eclipse twice.
Oh, and notice in Stellarium, you can think it's left of on this star right here. Yes, this is Regulus, which was actually visible in some of the pictures that Dr. Cudworth took. And so during the eclipse, I remember coming out and like looking up at other parts of the sky and just seeing like Venus and Jupiter up in the middle of the day.
Yeah, when totality happens, so to start my personal story, but when I was in Metropolis, Illinois, and got to see the eclipse, when I went on the trip, my professor always had a saying when it comes to like lunar eclipses and other types of things like that with the sun. Her saying was always, orbits happen. And so I was kind of that mind thinking, yeah, okay, I'm going along to help operate some telescopes during the eclipse. Orbits happen, they're pretty cool, I guess. I did not expect that when totality occurred and it felt like twilight and the temperature dropped and you could see the corona and the prominences around the edge of the sun, I was completely floored, and now I'm going to try to see every solar eclipse. Even though I've already witnessed one, I can't imagine the next one being any less exciting than the first one was.
See, I was like the opposite. I was waiting for this eclipse for like 5 or 6 years because I first found out about it when I was probably like 8th or 9th grade. I had started volunteering at a local community college's observatory in the northwest suburbs, and the education person there told us about the eclipse, and I was like, I'm going, I'm planning for it. I've got to wait 5 years. And I waited like 5 or 6 years for this to finally happen, and I was very happy that I went and I saw it, and there weren't any clouds, and it was just perfect outcome.
So you weren't let down?
No,
after
not
all
at
that
all.
waiting?
Not at all. It was insanely amazing. And I would do it again. I would travel down again to see it before.
Yeah, so shocking for all of you, both of us think everybody should go see a solar eclipse because they're really cool. And if you're watching this show, you probably also think that this is pretty cool. I'm seeing a really cool comment about a proposal during the diamond ring. That is pretty good. That's hard to top.
Wow.
You really have to have your relationship time out perfectly.
Right? And just to time that, like to know when the diamond ring is going to appear in the sky and to have everything ready, like.
It's almost a shame, though, that they were both then overcome during the proposal. Hopefully they go see another eclipse where they can just focus on the actual eclipse.
Right.
But now what I want to do is keep kind of our location changing, focus back on the sun, and show you how, depending on where you go, moving around on Earth really changes the perspective of where you are in looking at the sun and the moon. Ooh, we're getting close to totality.
Oh, nice.
There I got it again.
Wonderful. Good job.
And of course, as we said, it creates a fairly narrow strip. So if you notice, just moving slightly off, you don't get totality. You end up with just a partial eclipse. And of course, it moves across the country. So the farther you move to one side, time of totality will change. And of course, if you're over here in Africa, unfortunately, you were left out and you didn't get a cool solar eclipse on that day. Now, what we're going to do is we're going to go set it at Carbondale, because that's probably roughly the area that will be again. but 4 years from now. And for anybody wondering, we're just going to go ahead and pop up the date and time of that solar eclipse so you can get your plans ready now. So this one won't be in August.
April.
So 4. And it'll be on the 8th.
I think it was Jeff or someone in the comments that noted, oh yes, Jeff, that you have a lot lower chance of clear skies on that date, April. Got those spring showers coming. But fingers crossed that somewhere in the United States it won't be raining or cloudy.
Yes, let's hope somewhere we get a nice open sky. If anybody knows some useful rituals to create a clear sky, please share those in the comments, and then also send them in an email. Although, Jeff, I have to say, a snow shower during an eclipse would be kind of cool. Not gonna lie. As long as it's just, you can still at least somewhat see the eclipse. But here we go. So April 8th, 2024, right after 2, if you're in southern Illinois, is when you'll be able to see totality. And again, as I mentioned, just moving slightly does change when totality begins. So the best thing about Stellarium is it's free to download. You can put in your latitude and longitude of the location you know you're going to be at, and you can figure out to the second when totality will begin. You don't have to go online and look at those apps and the suggested times based on nearby cities. You can figure it out for yourself and look like a genius if you don't tell everybody else that you used a free program to figure it out. All right.
I think an interesting thing about this eclipse that I think I read that if you go to Chicago, which is not too far away, but kind of, pretty close still, I think it's supposed to be at somewhere around 99% full. So super, super close. Yeah, you got that little sliver right there.
Oh.
Yeah.
That is so close. So even if you're in southern Wisconsin or in the Chicago area, you can still get a telescope or get some solar glasses to be safe and watch a partial eclipse on that day if you're not able to travel down, or if you just really don't want to deal with the crowds. And honestly, I can't blame you, because they were pretty bad.
Oh, were they? Where you were? Where did you go?
So I was in southern Illinois, in Metropolis, Illinois, and they actually do have a giant Superman statue. So if you're ever in the southern Illinois, Kentucky area, do stop at Metropolis. It is a pretty cool statue in a cool little town. And we were actually staying at a hotel room in Missouri. The people I was with had it all planned out. We had 4 locations reserved. We were checking the weather the night before and that morning. So we picked our location, went to Metropolis, got to the park, set everything up. Weather luckily worked out, but we had other locations in Missouri planned out. And so part of our group left to go back to Missouri, go back to St. Louis. They went up the interstate by Carbondale, and then we went south into Kentucky, then went over and back up probably an extra 30-40 miles, and we beat them there by about 20 minutes.
Nice.
And they left about 20 minutes before us. So yes, the traffic, especially near Carbondale, since that was the city that was talked about on the news all the time, definitely made a big difference.
Because see, I don't remember exactly what city I was in, but I was by a lake at some preserve, and there were not the normal amount of people in the park, but there was enough room there that it felt totally fine. There weren't that many people, and so we just laid out a picnic blanket there, not an entire table. Yeah, but I remember we did tip, if you don't care as much about seeing the entire eclipse from start to end, if you live right after if you leave right after totality, so when the eclipse is still going, you can probably beat a good 3 hours of traffic.
Yeah, but it's also still fun to watch the partial eclipse after that.
Oh, definitely.
But you plan whatever works well for you. Uh, and if you want to check in on us, I guarantee we'll be having plans of some kind. So
Yep.
if you're ever looking for any tips, feel free to reach out. Now, we also did tease a little bit about Yerkes history, and we did check with Kyle on a couple of things. I did take a little liberty on an educated guess. One thing we wanted to talk about was many people know, as we mentioned in a previous show, George Hale's obsession was with the sun.
Oh, yeah.
That's what he liked to study, and so Katya did a lot of research with that. And one thing I based on some of the stuff we heard, I think it's pretty easy to say that the most observed object with the Great Refractor is the sun. I believe there was a picture of Edwin Frost holding up the 10,000th plate.
Bill Morgan.
Oh, it was Morgan. Bill Morgan,
yeah.
with the 10,000th plate from the heliospectrograph, and I'm pretty confident there are not 10,000 images or exposures of any other single object in the night sky. So the sun definitely was the primary target of the 40-inch refractor. And so Katya, tell us a little bit about what you learned with the 40 and that stuff, and I'll bring up some cool pictures.
Oh, that sounds awesome. Yeah. So, you might not think of Yerkes as a solar observatory. In its most recent past, it did not do much solar observing. The 40 was primarily used for outreach and nighttime programs. But way back when, it did a whole lot of solar astronomy. So, George Ellery Hale, he loved solar astronomy like way back, even when he was still in college. So he actually did solar astronomy at home as well. He set up a laboratory. He lived in like the Hyde Park Kenwood area of Chicago, so right by where the University of Chicago is. And he had his own little observatory there called the Kenwood Physical Observatory, and he had a 12-inch scope there. And so he went to MIT, and he actually did his thesis on solar prominences at MIT. And in order to get images of the sun, so sunspots and prominences and magnetic vortices and all of that, he actually invented an instrument called a Spectra Heliograph. And it is basically like a camera that you can use to take a physical image of the sun in one wavelength. And so this was completely new back then. And so he had one built, and he actually used it, and he moved his 12-inch over to Yerkes when Yerkes was built, and he became director of it. And he actually moved his scope to where the 24-inch telescope now exists in the northeast tower of the building. And then later on, they also built a much larger spectral heliograph for the 40-inch telescope that took all of those tens of thousands of sun. In addition to that, if you have ever been to Yerkes and you've been up to the second floor, you might have noticed that there is, by a stairwell, there is a very large, looming, and kind of mysterious elevator shaft. And going down the hallway, there is like a very long and horizontal kind of full thing. Like, you wouldn't really know what it is. It kind of looks like an instrument bench or something. And this was actually a sort of solar scope that was set up on the second floor, and the roof of that part of the observatory could actually roll off, so you could observe the sun at that time. Don't really know much about what kind of instruments or observations were taken there, but there is rumor, this is unconfirmed, but there's rumor that the rollaway roof was shut completely around like 1900s, but reopened and lifted to insert the first electronic computer into Yerkes. So it must have been pretty big. The elevator shaft, actually, that is on the second floor, was actually where a support pier went, so that the pier of your telescope would be completely separate from the building, so that any vibrations that were caused by, footsteps or whatever going on in the building didn't affect your images, wouldn't shake and wobble.
Gotcha. Did you want to talk a little bit about the images that I pulled up? These are
Right.
plates from 1904 from the 40-inch refractor.
Yeah. And so these were taken, what, a couple days apart?
I believe 3 days apart.
Yeah, 3 days apart. And so you can see how even in 3 days, the surface of the sun changes a lot. You have different formation and
Sunspots.
the opposite of creation. Yes,
Oh, yeah.
of sunspots. Yes. And different prominences and different solar features of the sun. Now, the sun actually goes through a cycle by which its activity, the activity on its surface, kind of rises, becomes very active, and then sets for a period of time. I think right now we're somewhere down low to where the sun isn't super active right now.
Yeah, I think we're still coming off of the minimum,
Yeah.
which was a couple years ago already.
Yes.
But yeah, as Tim alluded to earlier, the sun is still boring, unfortunately, most days. When I was first started observing the sun with a hydrogen-alpha and just a simple white light filter, it would happen to be the year before the solar maximum. So I was under the impression for the longest time that, oh, you can just go look at the sun anytime and see sunspots.
That's
Fortunately, not the case. But we have these cool images from the 40 of plates that were taken back then.
Another cool thing, so besides, the 12-inch and the roll-away roof and stuff, there was a horizontal scope called the Snow Telescope. That was originally actually somewhere in the south lawn of the observatory, but then the building that it was housed in unfortunately burned down, but somehow all of the electronics and equipment was survived, I guess, and so they rebuilt another house for it and observed there. And then in 1904, when Hale was moving over from Yerkes to Mount Wilson in California, he actually took this telescope with him, and it was the first real research telescope that existed at Mount Wilson. It's actually still there, but not really used for cutting-edge research anymore, but more for education and outreach purposes. See what a telescope from 100 years ago was like.
That would be really cool. I'm gonna have to talk, Kate. We need a glass field trip.
We do. Yeah. Neither Adam nor I have been out to California observatories.
Unfortunately. But hopefully one day.
The people who worked at Yerkes with Hale also tended, as I said, you need solar eclipses to observe parts of the sun like the corona, and so they did a lot of expeditions, a whole bunch of different places around the United States and around North America and more, and to other continents as well, to observe solar eclipses. And actually, Hale was so fond of studying the sun that he organized an international solar conference back then, which happened around, I'd say, every 3 years. And this actually grew to become the kind of, centerpiece or nucleus for the International Astronomical Union, which is still an ongoing organization that hosts meetings every single year.
Oh, that is really cool. I actually did not know that.
Yeah. So Hale kind of, could say, started a part of IAU.
All right. So one other thing, did you have any more fun facts from Yerkes? Good.
That's it. I mean, there's a lot more fun facts about Yerkes. But...
Yeah, we could spend hours talking about fun facts from Yerkes. And with Kyle on, I'm almost tempted just to have him jump on Zoom and tell us a couple more, but we'll have to save that for a future episode. I did want to talk a little bit more, because we did talk about, fun with the sun and all of the things that we don't normally think about, how the sun plays a role. One other thing that I want to point out, so a lot of times people will talk about, oh, there's an eclipse coming up, because people like to make those fake articles and send those out. If you ever see one of those articles and it's not from NASA or a source you trust, it's some random newspaper or some website you've never heard of, one thing you can always go do is just type in that date and look for the lunar phase, because you can only get a solar eclipse during a new moon. Obviously, all of the light we see from the moon is just reflected sunlight. So if you took the sun away, we wouldn't see the moon anymore. It would just create a big black circle and block out any stars in that area of the sky. And so there are just these little things that we don't think about, that even at night, the sun does play a role in our observing. And granted, as Conti and I are both unlike Hale, and we prefer doing our observing at night and looking at things really far away, the sun is kind of the bane of our existence. And so when the moon is full, that's also not the best for us, because it's just reflecting that much more sunlight, messing up all of our observations that we want to do.
That said, the sun does light up, all of the planets that exist in the system. So when we want to observe or image Jupiter, Saturn, any planet actually, then we rely on the sun. Because, again, those planets don't make their own light or anything. All just reflected sunlight.
I guess that's a good trade-off.
Yeah.
Deal with a full moon once a month, or a couple times a month, and but also still get those planets, because there's really nothing better than looking at Saturn or Jupiter through a telescope. And one other thing that we know about the sun, and so for a long time it was questioned whether or not the sun was the center of our solar system. Probably longer than it should have been questioned, but questioned for quite a while nonetheless. And one of the pieces of evidence was Venus. So one thing you can notice if you look down on the bottom right side of Venus, it's not fully illuminated. Because Venus is between us and the sun distance-wise, we don't only see the side that the sun illuminates, we see the side that faces us. And so if we bring up the date time window and we jump forward, let's go back.
Oh, you hit the little planes on Venus.
There we go. Oh, I know what we have to do. Sometimes turning off daylight can be very helpful. Oh, it's not going to let me do this. Alright, I guess we can't do that with Stellarium.
Move a bit forward.
Right. Alright, and so if we just kind of go change months, you can see where Venus changes relative to the sun. This is actually when it's closer to being full, because it's relatively behind the sun. But if we move back out, skip another couple months, Venus moves in its orbit and is now pretty far away from the sun. And as you can see now, it is nowhere near, it's now just more of a gibbous and not fully illuminated any longer. And so even right now, or recently, earlier this spring, Venus was in a great position to go and observe early on in the evening. And this was one of the first pieces of evidence that helped prove that the sun was the center. And there are some really cool drawings by Galileo observing these, and he drew out the phases of Venus. And so again, another wonderful thing about the sun is all of the things in our solar system that we love looking at that it illuminates. And one other really quick fun fact before we wrap the show up that I think is kind of fun. The sun, if you were to take kind of a full spectra, so we know about the visible wavelength of light, the sun happens to actually peak in the green area of the visible wavelength. And it just so happens that our eyes are perfectly adapted to the sun, and so your eyes are most sensitive in green, and so you can actually see more shades of green than any other color. So the sun is tied to all sorts of things that we don't think about, one of those things being our eyes and how they actually work. So next time you're out, look around, see other things that the sun plays a major effect in, whether it's just all of the plants in chlorophyll being green, whether it's just your eyes and start noticing, looking at different colors and seeing if you can really notice that green has the most shades of all of the colors, or at least the most distinguishable when you go through the different shades of colors.
Fun fact, the sun also happens to be the spot where we first discovered element that goes into our birthday balloon.
Yes.
So, a lot of people will fill up birthday balloons with helium. And helium, the element itself, was actually first discovered in the sun. And people, I think it was Eddington, one of the people involved in this, decided to take a spectra of the sun. And when you have a spectra, basically you can tell what kind of elements are present in a certain object by seeing lines of absorption and emission. And so they saw some lines that didn't reflect any current known element. So therefore they named helium after Helios, the god of the sun.
And yeah, so there are a ton of fun facts, and of course we didn't get to go over everything that's exciting about the sun, but there has to be quite a bit considering it was George Hale's obsession and the most viewed object by the Great Refractor. But with that, I want to thank all of you guys for jumping on and joining us tonight. I was happy to see the comment box going crazy. Hopefully we'll see you guys next week. Unfortunately, we'll be back to our normal setup, but it will still be a good show. So if you have any ideas of things that you would like to see us talk about, please either mention it in the comments or send us an email. Otherwise, you guys have a great night, and hopefully we get some more clear skies so that we can all go outside and observe ourselves.
Yes. All right. See y'all next week.